Today we will make the 3D design for the 13 product from the Tech Hub project, and let's see what product we had in these 13 products. So I will go to Smart Tech Hub, and after that go to the tutorials on the website. So go to Event, Learning, Teaching, Training, Activities, C2, Intensive Summer School, read more on this, and go down on page here to the PDF guides. Open them, and here are all guides from the project, and we'll open the certain one. And on this certain product, it's okay, it's an orbital spinner, and we can see a spinner here. And this is a proposed design. Of course, you can perform your own design, but let's see how this design should be performed. Okay, so let's go. Let's see first sketch. Okay, so first sketch is a circle of 22 millimeters. Okay, so take new part, open the part, and in this part create a sketch. First of all, switch to the sketch menu, take sketch command and choose a plane to create the sketch. Here we are. Take a circle, draw here a circle from the center of the sketch and put a dimension of 22 millimeters. Here we are. This is 22. After that, exit from sketch, extrude it with 7 millimeters and make a thickness of the wall of 4 millimeters. External, of course. I don't know why, of course. External, just external. Okay, exit from sketch, go to features, take extrude, say 7 millimeters, and here put on thin feature and say how many millimeters we said? 4 millimeters. Yes, so 4 millimeters outside, of course. And we obtain the ring. So now we had a ring here. Okay, let's see the second sketch. The second sketch is a circle with a diameter of 38 millimeters. Good. So just take same plane, look perpendicular to it, and create a circle with 38 millimeters. 38 millimeters. And I suppose that the parameters for extrude will be same. 7. No, it's not same, it's 2.5. Okay, and here is the explanation why. Because the first ring here will be a bearing. We will create an assembly and here will be a bearing. So this all should be 4 millimeters in order to be able to keep that bearing here. And the second one and the rest of the rings should be smaller with a small thickness, just that they are for design element. Okay, so go to feature, extrude, of course again 7 millimeters, same height, thin feature, and here is 2.5. Pok pok. Okay, so we had 2 rings already. Good, go to tier 1, and this is 48, let me check, yes, 48 millimeters. So repeat same, create a sketch, choose a front plane, look perpendicular to the sketch, create a circle, and here should be 48 millimeters. 48 millimeters, exit from sketch, go to features and take a look, 7, 2.5. Okay, so same parameters for the extrude, 7, and here thin feature 2.5 already set. Good, so this is the third ring. Good, and we had the fourth one, 58 millimeters. So repeat again, fourth time, 58 millimeters, like this, put the dimension 48, exit from sketch, rotate, go to features, take extrude 7, and here thin feature 2.5. Very good. So we had 4 rings, yes. And okay, so the fifth sketch is a circle of 30 at a distance of 28. Okay, so create again a sketch on same plane, on front plane, look perpendicular to it, create a circle somewhere here, yes. And what I know about this circle, the center of circle with the origin of the sketch should be on same vertical dimension. The circle should have 30 millimeters diameter and 28 millimeters distance between centers. That's it. Yes. Yes. And after that, apply and extrude with 7 millimeters on this circle. So it will be a full body. Just go to features, take extrude and say 7 millimeters of this. Okay, and how you can see, this cylinder connect all the rings together. Okay, and what we will do next? So we will do switching, sketch menu, choose surface on previous step. 25. Okay, so we will cut. So here create a sketch, and in center of this circle just create another circle with diameter of 25 millimeters. Good. Exit from sketch and extrude cut this circle. In order to obtain, here should set a true hole option, and we obtain a hole inside of the cylinder, and now this is also a ring. Yes. So with this ring we will go further, and here after circle was created, use extrude cut. Yes, we used it. Okay, it should be at 45 degrees. So what we should do, we select draft on and say 45 degrees, and this will be like this. You saw? And it should be just 3 millimeters, not 7. Yes, so here not true hole, should be blind, and 3 millimeters. Yes, something like this. 3.5, sorry again. Yes, 3.5 instead of 3, like this. Good, so we obtain this. After that I will do a circular pattern of this around. But I think first of all I should create a mirror. So I will choose a mirror and say that I want a mirror. Mirror plane will be between these two. No, it's done to the work tag, like this. So I take plane and say between this and this surface create a plane. So I have the middle plane, you see it. Yes. And now just take mirror and say between around this plane mirror this feature, and I obtain this. Good. Hide the plane and now create a circular pattern and say around this circle I want equally spacing at 360 degrees, 3 features. Which features? This one, and of course this one. Something is not work properly. Let me check what doesn't work. And if I do justice, yes, this work. Let me check again, circular pattern, and I want this. Here, delete and say around this. Nope, it doesn't work. Let me check circular pattern around this one, and I want to take this cut. Yes, it worked. Mirror, and now try on this plane to mirror this. Yes, so I obtain what I want to obtain. Yes, good. So I have the body, and here is the body. Let me see if we had another feature. No, now we convert it in STL, and we save it like format. But first of all, I want to do a chamfer, a small chamfer of 0.5 millimeters on one surface, on this edge. Yes, here we will assemble the bearing, so I want to have a center surface here. Okay, just save spinner body. Yes, spinner, save. And I will show you how we can bring the bearing and assemble it with a bearing. But first of all, I will close this, open an assembly. Yes. So now we are in assembly. We will go to design library, open toolbox. Yes. So I open toolbox, go to unsymmetric, I need bearings, I need ball bearings, and I need an radial ball bearing, of course. And from here, from the list, I will set up the setting for this bearing. So I know that the bore is 7, the out diameter is 7, and the thickness is 7. So I want full detailed with cage and full show, yes? So just validate. This is the setting for the bearing, yes? Just say, I open this bearing, yes, because I want to save it like a part, this one, or I can just directly assembly, yes, directly in assembly, insert my own component, the spinner, and bring it here and assembly with this bearing. So I say mate this hole with this cylinder to be concentric, this surface with this surface to be aligned, and now my bearing is constrained here. And of course I can make this to rotate, go to motion study, say motor, rotary motor, of course, and I want around this to rotate the body, yes, body to go on loop, yes, and now just look how this works. So around my bearing, the body of the spinner is rotating. Just stop it, and that's it. That is the certain product. It's a spinner that we will make, we will manufacture it with additive manufacturing. Thank you. See you on the next video. Bye.